Dear students, now we'll see various cases of displacement versus time graphs. First, we'll analyze these three graphs which are shown here. The very first graph you can see when we talk about displacement versus time, it is a horizontal straight line. So if we talk about the slope of this line, it is obviously 0. So here we can write the velocity of particle is 0. That means this directly denotes the particle at rest. Whenever a particle is at rest, its displacement time graph will be a horizontal straight line. If we talk about this situation 2, where we can see again it is a straight line at every position, if we find out the slope, its slope remains constant. So in this situation, the velocity of particle can be written as tan theta, which is positive. So it is the motion of a particle which is having positive velocity, or we can state a particle moving away from origin. I have written away from origin because you can see with time the position or x coordinate of particle is increasing, and at every point its slope is constant, or at every point it makes constant angle with the time axis. So particle is moving uniformly. So you can state particle moving away from origin at constant velocity. So this is the way how we analyze such type of graph where there is a straight line having constant slope or constant angle with the time axis. If we talk about this third case, we can state here the angle made by the line with the positive direction of time axis is obtuse. So here if we find out the velocity, still it is tan theta, but it comes out to be a negative value. So you can state here as time increases, x is decreasing. So we can state it is the graph of a particle moving toward origin at constant velocity. Again we are taking velocity to be constant because at every point of time in this straight line the slope with the time axis is a constant. So these are the three motions you should always keep in mind, because in various questions we need to combine such type of graphs. Let us see some more displacement time graphs. If we analyze one by one these graphs, then in graph number 4 we can see, if we talk about a displacement time graph, this is a graph in which we can see particle starts from origin at t equal to 0 with a particular slope or velocity. But you can see when the particle moves, if we draw the tangents to the particle at various times, say we draw it at time t1 and then we draw it at after some time say t2, then you can see the angle which the tangent makes with the horizontal is decreasing. That means in this situation when we talk about velocity of particle, it is tan theta. You can see here theta is decreasing, it is coming down. If velocity is decreasing, we can say the particle is retarding. So in this situation at every point you can see this velocity is positive but it is decreasing. So here acceleration we can call it to be negative, because when acceleration direction is opposite to the direction of velocity, then only the magnitude of velocity decreases. So this is the case where we can say a particle is moving with the positive velocity and negative acceleration. That means acceleration is negative opposite to the velocity. That means the magnitude of velocity decreases. It is a retarded motion. Similarly, when we talk about this graph number 5, you can again draw the tangents at time t1 and t2. In the beginning at t1 and after some time at t2. You can see we draw the tangents after some time at the higher time, the angle which the tangent is making with the positive direction of time axis is increasing. So here again we can state that velocity is equals to tan theta, which is positive but it is increasing. So if velocity is positive and increasing, that means acceleration vector is also positive, because when acceleration is in the direction of velocity, then only it increases. So it is a motion which we can consider as a particle is moving with the positive velocity and positive acceleration. That means it is a situation of an accelerated motion. Now we talk about this curve number 6. Here again you can see at two different times t1 and t2. If we draw the tangents, you can see at time t2 the tangent is steeper than the tangent at time t1. That means here, as it is making an angle obtuse angle, it is making an obtuse angle, the velocity will be negative. So here velocity we can write again tan theta, which is negative, but as the steepness is increasing, this is also increasing. If velocity is negative and it is increasing, that means acceleration is also negative. So we can say particle, this is the curve for a particle moving with negative velocity and negative acceleration. And if velocity and acceleration are of same sign, this is the case of an accelerated motion. Similarly, if we talk about this curve 7, you can see that the steepness of tangent is decreasing from time t1 to t2. And as again the tangent makes an obtuse angle, the velocity, which is tan theta, is negative, but it is decreasing. So if velocity vector is negative and it is decreasing, that means acceleration vector will be in the direction opposite to that of velocity. It must be positive. Like in this case, again we can see the velocity is negative, the vector is negative, but it is increasing. So acceleration we have taken in the same direction of velocity, it is negative. But here, as velocity is negative and it is decreasing, the acceleration must be opposite. This is the case which belongs to a particle moving with the negative velocity and positive acceleration, which is the case of a retarded motion. So always remember these graphs and the way how we are analyzing that which graph is corresponding to accelerated motion and which graph is corresponding to retarded motion. So all these graphs we are required to combine in case of a motion in which particle is accelerated as well as it is retarded. We'll also see some examples based on this. In this example, we are given with a tower over which a boy is standing who throws a ball up with a speed u. It goes up and finally it falls on the ground. And you can see it says a boy on the top of a tower of height h throws a ball up with the initial speed u. Now taking upward direction positive, we are required to draw the displacement versus time curve for ball's motion till it hits the ground. We can say if the starting point where the ball was thrown at t equal to 0 is taken as origin, and upward direction we consider as positive x direction and downward we take as negative x. So we can say it first move in positive direction. At some point of time its velocity becomes 0 and then it falls back and final displacement will become x equals to minus h. So we draw the motion. We can take initial velocity as positive. Throughout the motion its acceleration is downward g. Then acceleration we can take as minus g or minus 10 meters per second square. If we draw the graph for this motion and if we draw the displacement time graph, it starts from x equals to 0 at t equal to 0. Say at a time t1 it reaches a maximum height. Say maximum height is h1. So we can say this is the height h1 where it reaches at a time t1. So this is the motion where velocity is positive and acceleration is negative. The graph will look like this. This is the graph for positive velocity and negative acceleration where it reaches the maximum height. And as we already studied, it will take the same time in coming back to the starting point. So at time 2t1, it will reach again back to the origin. So at time 2t1, it will come back to the origin like this. Here again x becomes 0. And say at a time t2, it will finally hit the ground. So we can state this graph will be further progressed, and at a particular position, the time will be t2, and at this position, the displacement will be equals to x will be equals to minus h. So this will be the complete curve. This is just the extension of this downward curve by which the particle will reach the ground. So this is the complete displacement time graph for the motion starting from the hand of the boy, reaching maximum height and finally hitting back to the ground. In this example, we are given with a car which moves at a velocity v0. If at t equal to 0 time, driver sees a need to apply the brakes and applies the brakes at a reaction time tr and finally comes to rest in a distance s after brakes are applied. We are required to draw the position time curve for car's motion. Now in solution, first we'll draw the realistic situation. So if this is the car and at t equal to 0, car was moving with a velocity v0 and the driver sees that he needs to apply the brake. So in this situation, up to the reaction time, the car will travel at a uniform speed v0. So car will travel a distance that is equals to v0 into tr. And at this position or at this time after tr, the brakes are applied, so car will be retarded and its velocity starts decreasing, and after some time its final velocity becomes 0. It is given that when the brakes are applied, the car travels a distance s. This is the retarded motion, or you can simply state this is the motion when velocity of velocity of car is positive but acceleration is negative. And in first part of journey, it moves with a uniform velocity. And now if we draw the velocity time or displacement time graph for this motion, we can simply state first part of motion will be a uniform motion. So displacement time graph for first part of motion, that is from t equals to 0 to t equal to tr, it will be a straight line like this. Straight line with a positive slope, and here tan theta can be written as v0. This is up to time tr. And from this time, the car starts retarding. If it starts retarding, the acceleration becomes negative and finally it is coming to rest at a time say t final. So we can write at this t final what is happening. The slope of this curve should become 0. And the final position where it becomes 0, this position will be the distance which is v0 tr plus s. Up to this time tr, it will be covering a distance v0 into tr. Finally, it has traveled v0 tr, the displacement or distance covered in the reaction time, and further it has covered a distance s. So this is the distance s which the car has traveled in retarded motion. So this is the final displacement time graph, first part of which is a straight line which represents uniform motion. Second part is a curve which shows velocity is positive but acceleration is negative. So this is the retarded motion of the journey. This is the curve which is required to be drawn in the question.